This video shows how to use chain rules to find the derivative of a composite functions. So what is chain rule? Chain rules is the rule that help you find the derivative of composite functions. For an examples, if we consider the function's square root of 2x. So the square root of 2x is a composite functions because we can see that the outer functions is square root and then the inner functions is 2x. If we let f of x be square root of x and g of x be 2x, then the function f compose g of x is gonna be the function square root of 2x, where gx here is the input of f of x. That means wherever you see x, you just need to replace the whole function g of x into x to get the functions f compose g. So what is chain rule? The chain rule is a rule that helps you find the derivative of the composite function f of g of x, and is determined by the derivative of the functions f in terms of g of x multiplied to the derivative of g in terms of x. Keep in mind, this derivative here is the derivative of the outer function f in terms of g of x. That means you want to find the derivative of f, but then the input of that function should be the function g of x. And this is the derivative of g of x in terms of x. That means you want to find the derivative of this function g, and then the input should be just x. Another way, if you rewrite g of x in terms of u, then the function f of g of x becomes f of u, and the derivative function is going to be just the derivative of f in terms of u multiplied to the derivative of u. Okay. Let's look at an example. Look at the functions f of x equals square root of 2x. We want to find the derivative of this function. Again, we know that this is a composite function. The outer function is square root and the inner function is 2x. So if we let u equals 2x, then we can find u prime, which is just 2. And then the function becomes the square root of u. And then we can use the formula to find the derivative of this function by finding the derivative of square root of u and multiply to u prime. As we know, the derivative of the square root of u should be 1 over 2 times square root of u times u prime, which is 2. And at this point, we have to review u in terms of x. So we replace u by 2x, multiply 2, simplify the 2 on the top and the bottom to get your final answer, which is 1 over square root of 2x. Now let's look at another example. In this example, we want to find the derivative of a composite functions, but this composite functions involves 3 different functions. You see, we have one function is square root, another function is sine, and another function is 7. So this function is called a function composed another function. So how can we use chain rule to find the derivative of this function? We think of each functions here as a box. So we have a biggest box, the most outer box representing for square root. Then you go to another box representing for sine, and the most inner box representing to 7x. We're going to find the derivative functions by first looking at the inner box. Find the derivative of the most inner box. So the derivative of 7x is 7. And then you go to the middle box, the green box. Find the derivative of these functions in terms of the red box. That means the derivative of sine in terms of 7x to get cosines of 7x. And then you go to the most outer box, which is the square root functions. So the derivative of the square root functions is 1 over 2 times square root of whatever inside this green box, which is 7 sine of 7x. Once you find the derivative of these three boxes, then you just multiply this derivative together to get the final answer of the derivative of this function's square root of sine of 7x. As you can see that 7x, derivative of 7x in terms of x is 7. And then if you let u equal 7x, then the derivative of sine of u here will be just cosine of u, which is cosine of 7x. Lastly, if you want to let v equal sine of 7x, then the derivative of the square root of v will be just equals to 1 over 2 times square root of v, which is 1 over 2 times square root of sine of 7x. So this is our final answer. All right, go to the next example. In the next example, we have another complicated functions that involved 4 different functions. Cube functions, cosine, natural log, and 1 over x. Since we have 4 different functions, we should have 4 boxes that presenting for each of the functions. Okay, we have 4 boxes: green, red, blue, yellow. Again, we want to find the derivative of the most inner box, which is 1 over x. So the derivative of 1 over x is negative 1 over x squared. And then we go to the next box, find the derivative of natural log. The derivative of natural log is 1 over x. But then now we need to find the derivative of natural log in terms of this blue box. That means the derivative of the natural log of this green box here is 1 over 1 over x. And then we go to the next box, the red box. The derivative of cosine of the green box is going to be negative sine of natural log of 1 over x. And then the last box is the representation for the cube functions. And using the power rule, we know that the cube functions, derivative of the cube, which is 3 times to the red box square. So then we're gonna, to find the derivative of these functions, we multiply these 4 functions together to get your final answer. And derivative of this red text here, if you simplify it, it's just gonna be x. And you can simplify this answer a bit further by multiply x, divide, cancel x and x squared. So this presenting you the derivative of a composite functions of 4 different functions using 4 boxes.